Okay, so we're gonna talk about this subject. I will explain a bit more what I mean by modern CuteQuick component and application. So let's start. Quick presentation. It's not about me, but so my name. Okay, I work as an embedded software engineer. I do some Qt trainings, architectures for customers, etc. And at Adeno Embedded, which is based in France, we have an activity on BSP creation, even for custom BSPs for Windows CE, Linux, QNX, etc., etc. So we are really embedded oriented originally, and now we really expand on the software side to have these skills from the bottom, from the BSPs up to the software, and be able to provide our customer all the things they need from the bottom to the top to the final application, and also an activity on mobile expertise. And that's all for the presentation. Okay, so here is what I mean by modern application. So right now, what people expect out of user interface is something like that, of course. So if you talk sometimes to your customer or even you, when you have a touch screen something, you expect something that looks like one of these three. I will not name anyone, but one of these three, which represents a really, I would say, modern user interface, something you will quickly be able to use, and yeah. And so that's what I call the modern feeling. So it's really vague right now. So it's achieving the look and feel you have on this kind of devices. So this is quite general presentation. I will not be able to detail everything, but I will give you the tools to make this kind of experience. And it is a bit focused on embedded device, so sometimes I will explain a bit more specifically for Linux embedded, as this is the subject. But apart from that, it applies to all operating systems. So we have this modern feeling, and around that, I would say there is this kind of elements. So you have one first, which is the touch and gestures, which is really easy to handle in QtQuick. So that's one great thing. All the animations and effects. So in all your smartphones, this is not something blinking from page to page. We have animations everywhere. That's what we'll talk about quickly. Graphical acceleration, because of course all these things are nothing if your device is not fluid and responsive. And finally, quick look at sensors, and particularly how to use the accelerometer to, for example, adapt the screen orientation to the orientation of your device. Before explaining those four subjects, very quick reminder, I think more or less everyone here is doing QtQuick as a beginner, or maybe not beginner, I don't know. But I think you are familiar with that. So there is two main ways to create your QtQuick QML components. The first one, the easiest one, is to create a collection of QML, a file containing a collection of different elements that you arrange as you want. Of course, that's really quick and easy. And the drawbacks that it's limited to existing components. So when, for example, if you're trying to create an ellipse in QtQuick, that seems very simple, but that's not something available. You can create rectangles, etc., but an ellipse, right? No. So you have to go to the C++ side. And the look is something like that, of course. So you create your QML file, you put everything in it, and then in the code, you can simply use my component in your QML code. So the easiest way of creating it. The microphone is okay? Yes? No? It seems to vary. And the second way is to create it in C++. So in C++, of course, it's a bit more work, but you have all the power of the C++. You have all the possibility to draw the component exactly as you want. And you have also the possibility to handle the events exactly as you want. So in this case, we'll see both approach, depends. But just a reminder about the two ways of creating QtQuick components. Creating a simple file with existing components and creating a C++, one or more C++ class. And of course, it will look like this since CuteQuick 2. So you inherit QtQuick item, you create your class, and you do what you have to do. So for example, here we simply handle the mouse press event. Okay, and let's start with the multi-touch. If you have any questions during your presentation, if it's a short question, don't hesitate to ask it. Else, there will be a slot for question at the end, of course, and don't hesitate also talking to me offline at the booth at Eneo Freescale or right here. Okay, so multi-touch, plugin, and events. So gestures are part of everyday UI, of course. When you are using, for example, Google Maps on a smartphone, you don't zoom with a plus and minus button. Usually you just do the pinch gestures and you zoom in, zoom out. Same thing for drag, for rotation, etc. So it's really something that now is everywhere and a very natural way to interact with user interface. And that's why it's part of the modern feeling when you create your application. And Qt provides different ways of handling multi-touch. Just to let you know, it's a bit more involving than single-touch operation. Of course, single-touch is, we can say, quite limited to mouse area. You have your mouse area, you do press, release, etc. With multi-touch, you have more possibility, but it's also, I'd say, more problems sometimes. So it's a great thing, but yeah, again, a bit more work. Okay, so first, the requirements. So it really depends on your target. If you are targeting smartphone, I think this is not something you have to worry about. You have already the drivers and everything, okay? If you are building your own embedded device, you have to look at these things. So the first one will be to have a screen that supports multi-touch, of course, which is not the case of the cheapest resistive screen. So the usual one is a capacitive screen. You need the appropriate driver. So depending on the platform, you may have to create your own driver, more or less. Most of the time we can use, no, forget it. You have to include your own driver. So if you are, for example, on Linux like we do here, we have to install the right driver corresponding to the screen. So I will show you on my board I have, and we use a driver specific for this touchscreen, of course. But usually, again, that's not something you have to worry about. Just ask someone that will make the work and give you the results. And the last part is the plugin, because depending also again on the platform, etc., not all Qt plugin handling input manage multi-touch events. And the one we use on Linux embedded will be FDevTouch. So basically there is, I would say, two. The first one is TSLib, the second one is FDevTouch, and TSLib has no real support, at least with the Qt plugin, for a multi-touch, so you have to use this one. And when everything is set up, you can enjoy multi-touch events in Qt and worry about the rest of the work. So that's one example that I had to finish this weekend, of course, to have something working. And probably I can show you from here, but I think if you want to see more, you will have to come to our booth at Eneo Freescale. So here, for example, we handle the pinch gesture, and we have this slide gesture, etc. You set up your UI as you want, and at the end you say, okay, I'm done, and you have a wonderful clock with a tiny clock here, but you can also resize it. All those components, etc., and something fluid and handling multi-touch. So this is more or less the result. You can do something different from that. It's not a problem, of course. I encourage you to do something different than that. In our case, so this demonstration is based on a Freescale board, which is a Saber SDP, which has IMX6 dual light, so to make an echo to the keynote at the very beginning. The touchscreen is a Nigalax 10-inch, so just had to give some betting information, and it's, of course, a capacitive touchscreen. So here, with people at Adrien, not me, because I'm really not an expert on low-level Linux, etc., but one guy installed the right driver on the right board with the right Linux, etc., to have it work, and then hand me the board and say, okay, it works. I said, thank you. And the distribution is Yocto. So 1.5 or 1.6, so Daisy or Dora, I don't remember, with a kernel 3 something. Well, that's very important. And on the Qt side, we use fdev-touch, and so the command line to start the application now, provided you have compiled it, when you have compiled your Qt application, your Qt library, the complete Qt library, is fdev-touch using plugin. I don't know if you all guys see, but minus plugin, then fdev-touch, and 2 dot, the path to your touchscreen driver. So here it's in /dev input touchscreen 0, and so it will handle and probably work if you have the touchscreen and the driver. And then we use, in this case, I use the pinch area and a custom component to handle the layout, management, etc., etc. We'll see that there is different way to do it. And so if we go quickly, if it works, okay, I have the virtual machine. Of course, not working from Windows. If we go to a, let's say here, and we can use ftest, which is a small binary to just look at the touchscreen events. Touchscreen 0, okay, and when I press, tons of information. So now we have enough to say the driver side works. We can pass that to Qt, and fdev-touch plugin of Qt should work. Okay, and if I look at the run command, maybe I will take some time. No, show it after. Oh, go back. And so the command line in Qt Creator that I use to start the application, exactly this one, minus plugin fdev-touch and dev input touchscreen 0. Okay, so now we have the touchscreen running and we are ready to use it. So let's use it. Several components are available in Qt. The first one, the very basic one, is mouse area. Actually, we are handling touch events, but touch events automatically convert to mouse events when they are not handled. So using mouse area is still completely valid in this case. It will handle, of course, single touch, not multi-touch, and can be very helpful when you simply want to handle press, release, or tap gesture. The second one is flickable. So the flickable is the base class for example, all the list views. And this behavior you have when you try to drag it and it continues moving. Maybe it's called flicking, I don't know. I'm French, so I really don't know. But this inertia when you move the list view is provided by this flickable, and you can use this flickable actually on top on every component you want. So simply with this one, you will have at least this modern feeling of the UI moving, really moving under your finger and continuing moving. And the real touch components are the pinch area. So this one automatically handles for you at least, I think not two, just 2 finger, only 2 finger, and will give you information about drag. So when you move a component, scale when you do this pinch gesture, and rotation. So from this component, you will have on pinch started, on pinch updated, and pinch end, I think. And in each time on these handlers, you will have these 3 information: drag, scale, and rotate. So if you want to manually handle those information, you can just directly pass them to your application the way you want. I can show you a quick example. Multi-point touch area lets you manually handle every single touch point. So this one is very powerful, but you have to do a lot of the magic things underneath manually, so it will not give you scale information. You just have the finger points, and after you do what you want with this information. And the last solution, there is a mouse on it, is custom QQuick item, yes, creating just a custom class. And from this class, you can set this one to true, set accepted mouse buttons. Usually you set simply left. No, actually, that's not related to touch. That's something I wrote, but not related to touch. If you want to handle mouse events, you set this one to true, so it will also work with a single finger. And if you want to handle touch event, you have this handler, touch event, passing parameter a pointer to a QTouch event, and you will be able to have information about this touch point. Okay. And a few tips to finish, I think, yes, this small part about multi-touch, and I'll show you a very quick example. So touch events converts to mouse event, to simple mouse event when not handled, so that's one great thing when you don't want to bother with multi-touch. Pinch area sometimes interfere with mouse buttons and the clicked signal. So if you have a pinch area and mouse area and you handle the clicked, sometimes it will not work after. So you have instead, for example, to use the press signal, and in that case that will work correctly. As soon as you start using multiple pinch areas and items like that, it becomes really complicated because the events and the way events are handled is not always very clear when you use it from QML, for example. The other one that I use is set filters child mouse events. When setting this one in an item in C++, you will receive all the events from children of your element from the C++, which is very powerful because, for example, with this layout where you have where you have components that you move. In your components, you can have mouse areas or elements that handle the mouse. And what you want to say in this case is, I just want to handle the mouse for all this area, and I don't care about what's inside. I want to override and filter all these events. In this case, you can use this one, and in this one, you will receive all the events and choose to filter to handle them yourself or not, different events. And you have grab touch points to keep touch point for you and not have them received by other elements, and set keep touch grab, which is the same except that events will not be filtered. Okay, and if I show you something very quickly, if I find my mouse first, where it is, okay. Somewhere in this application, okay, so that's a very simple one. We use QtDD to provide some easy component, in that case only the virtual keyboard, but that's not very important. If we look at the main, not main, no, you can look at that, yes. So blah, 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 some code. Doesn't work. Button, 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 and here. Okay, so I created one class which is, for example, in this case, called it gadget layout. It's not related to Windows gadgets, just I didn't want to use widget and couldn't find a better name, so. Gadget layout with an ID, etc. Set a size, set number of rows and columns, and inside you put directly your elements, and this layout will handle automatically how items are positioned in the layout to match all the grid cells and everything. And if we look at these three, so for example, the clock used an enhanced gadget component, and this enhanced gadget component finally have one pinch area in it. And what I do in this pinch area, so this one is enabled only when you edit the layout, in our case, for example. And what I do here is I use the onPinch started and, okay, do some initialization. OnPinch updated, I pass this value, the pinch.scale, which is, should make it bigger. You see something? Yeah, try to do that. If someone can, I don't remember what it is. Control Shift plus? Or just plus? No, just control. But it doesn't work. With the pad, it doesn't work so well. Thank you. Perfect. Found it. Let's say 20. Oh, that's quite big now. Okay, so simply in this pinch updated, I use this value, the pinch.scale, which directly returns the scale which is calculated from the gesture you do. So in this case, you can directly use this information here. I didn't use the multi-touch point area, not the exact name, because in this case it's not necessary, but that's one usage, and it works quite well. And yes? Okay. If you have a quick question, don't hesitate. Just pass it fast because there is a lot of things to see. Now remove this virtual machine and continue. Okay. So now I pass you all the details. Of course, there is some work to do, but you have at least the tools, the filtering, the mouse areas, handling touch, point, event, etc., etc. From that, it's really, your choice to see how to handle it. It's difficult when you start handling touch event manually. For example, if you want to combine scale and drag, this kind of thing, because you have to use some threshold to detect when you start using 2 fingers or 1, and when you should drag or not drag, and scale and not scale. So when possible, using Qt components directly make it a lot easier. And when you need more flexibility, you can use the types more low level, like the multi-points and the touch event directly. And now the second part is about small effects and, small effects, animation, and shaders. Okay, one nice image. And that's all, that's a nice image. So effect can provide, the final polish. Actually, it's really important. It's available in QML. It's really easy to create animation and to add effects. So I would say just go for it. It will add a lot to your application, and it will make it a lot better. The feeling will be a lot better when using it. So you have two different things. No, several different things. Animations that will provide user friendliness. Usually we use animation to really give information about what is done. So for example, when you switch a page, when you open a component, etc., the animation will provide information about where is the content that you clicked, or this kind of stuff. So animation is just not about creating a random animation and that's all. It should be linked to the functionality you do and what it means. So if you open a pop-up, for example, you don't make it show from, I don't know, a random animation. You can make it appear, like I think on iPhone, something like that, from the center and make it grow. When you go to another page, if it's on the same level, usually you go from the left to the right, something like that. So an animation that brings information really. The second thing is blurring. So blurs are actually quite useful to make some elements stand out. And the last is, with effects, Qt effects, you can do a lot of things that are not specifically for user interface or adding a feeling or anything, just make effects. So you can also enjoy all these different effects. First, talking about animations, you have that in QML, behaviors, property animation, and state and transition. So if you have, for example, a button and you want to animate the X coordinate each time it will change, you can use a behavior like that. You write behavior on X, and then number animation, and here, every time your button will move, it will be animated, its X coordinate will be animated directly. So it means you don't have to stop animation manually, it will automatically work. So if you didn't know, that's one great thing. And the thing is, from C++, you cannot, of course, create something like that or create an animation and a binding. It's possible, but sometimes it's not the best way. So you can handle animations directly from C++, from your custom component. And to do that, we have one class that exists since a long time, which is QProperty Animation. And it's actually quite close to the QML animation. So you will create your animation object and you will animate a property. The limitation is that you can only animate QProperty. So if you know from QML, everything you modify, every property you set up is really a QProperty. And so from QML, from C++, sorry, that's the same thing. If you want to animate something in your object with this one, you have to declare it as a QProperty and at least have the setter, or actually getter, setter, and also the notification if you want to be notified. And it is used like that, so it's quite simple. You create your QProperty animation, probably not on the heap like that with a new, but that's just an example. And then you have set target object. So for example, if we want to animate the component that we are using currently, the component we are in, set target object this, set property name, so that's the property that will be animated. Here we have X again, which is already a property, so no need to create one. For CuteQuick item. We set the duration, we set the end value, and we have start. And as for QML, you have also the easing curve, the easing type, sorry. I don't know why it didn't include it. No, it's visible here. The easing type that you can set up in C++ with set easing type and passing the type as in QML. I didn't write it here, but the easing is also very important. So basically, the animation, when you create animation, it will be a linear animation. So it will be something very boring, I'd say, where it will simply move always at the same speed. If you want to really take advantage of your animation, you have to use this kind of easing. So for example, the out quad, that will make it fast at the beginning and then slow down, making the animation more natural. So you have to create your animation and you have to use this kind of easing, easing. Easing out quad is the one I use probably most of the time, so it's not a bad one. Okay, and then we have this. So it's very visible since one of the update of the iPhone. I don't know. I do not have one, but I have seen it already. So when you have something on screen, dialog or something, a menu, you have the background which is blurred like that. And the blur is really not only an effect to add some eye candy, it's an important effect to make this part stand out really and focus on the important part of the application. So in that case, that's one effect that really adds also content, that add natural feeling to your application. And so to use this, for example, you will have to import Qt graphical effects. And you have a big list which is available. I do not make the complete list because there's a lot. If you look for that on the internet, you will quickly find it. On the blur side, you have the Gaussian blur, fast blur, recursive blur, etc. Fast blur is usually enough to be used. And it will simply let you fade one part of your user interface. So you use the fast blur, you focus you make it fill one of the item you want to blur, and when enabling it, it will have this effect on the component. And so if you have it on your complete interface and show a dialog on top, you can blur the complete rest of the application. And the second one is drop shadow, glow, rectangular glow. This also adds, make a component stand out from user interface, but instead of adding a blur, they add some, glow or shadow to your component. Still, it's quite a nice thing because the drop shadow, I would say more the drop shadow, is something that's very visible now in modern websites, for example, where you have your component and shadows, etc. And so it also adds this modern feeling to your application, the shadows. It's probably obvious, but these come at a cost. So if you use them everywhere in your application, it will probably kill the performances, but that's one thing. They are implemented with shaders, and after you can, so you can also write your own effects with, I didn't wrote it here, effect shader, I don't remember. In QML, you have one component that should let you write your own shader. So if you are familiar with the the OpenGL shader language, you can write your own to make this kind of effects manually. Okay. So it doesn't time goes fast. I need to show again a lot of things, so I will probably go fast. The next part is about, well, really making it faster, so I should do the same, and using OpenGL to accelerate the drawing of your components. So, blah, 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 blah. Can skip that a bit. The important thing is now CuteQuick is based on OpenGL, and so leverage OpenGL acceleration. And if you are running on a Linux embedded, you can use this one, platform EGLFS, if it's not already the default, that will use this specific backend, and this specific backend provide OpenGL acceleration. If you use, for example, the Linux FB, yes, Linux FB, which is very low level and directly rating to the frame buffer, you have no Linux acceleration, no OpenGL acceleration. So in that case, that's usually the one to choose. If you have X, of course, it will be XCB that also provide OpenGL acceleration. But if you have no graphical server, it will be EGLFS. Blah, 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 blah. So CuteQuick 1 was using Painter, so you had the paint, but now it's no more available. And with CuteQuick 2, we have CuteQuick item that has no paint method. So with no paint method, it's quite difficult to paint our item. So we'll see there is, of course, another solution. The first one is to use CuteQuick painted item. So this one is a convenience class. It was made partly to make the transition easier between CuteQuick 1 and CuteQuick 2. And it lets you write the paint method with a QPainter, just like you were able to do it with Qt 4. So you will find back this method, and you can write your code just exactly like before, and that's perfect. Problem is, it will not fully leverage the scene graph optimization. So the scene graph is the thing behind CuteQuick, and doing all the optimization and making sure everything is good. Well, you will not leverage this optimization nor OpenGL completely. So it's perfectly suited when you have something light to draw, but for example, if you want to draw curves accelerated graphically, and you want to update these curves really often, in that case, probably that will not be enough if you have a limited performances, limited power, CPU power on your platform. Okay, so scene graph is this, blah, 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 render thread, and blah, 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 blah. Yes. Not important anyway. The important thing is with the scene graph, all the things all your components are based on nodes, are considered to be nodes. For example, when you create a rectangle, internally that's really a rectangle node. And when you want to draw manually your component using OpenGL acceleration, you have to manually create these nodes and handle these nodes. So actually that's quite a work, but that's completely possible. So here we have, for example, one parent node, just like you have one parent item, you can think it the same way, and 3 different elements that contains other elements, etc. So each node can have children and a parent optionally. And node can be a visible thing or just provide functionality, so you can have nodes that provide the opacity functionality, and another one that can provide the transformation capability. So to be able, for example, to rotate and to transform the drawing of your component. So that's like items in QML, but a bit with actually more things to do and even more nodes. So when you want to leverage this one, you have to inherit CuteQuick item. In the constructor, you have to set the flag item as contents. That's a bad thing. Of course, I plugged it. And now, no CPU power, no power on the computer. Sorry, I disappeared. I will come back soon. I hope the computer will come back too. We were talking about? QSG nodes. Yes. Yes. And scene graph, yes. Oh yeah, we were talking about, yes, the set flag item as content. It's really dead. I think it's disaster. Always at the worst time. Okay, so waiting for it to restart. Probably it will. because there is some LEDs. Wow. Oh no, that's the waiting screen. Okay, thank you. I restart it. Okay. So you have to set this flag in the constructor, and after you will have to handle one event, which of course I don't remember the name, to re-implement UpdatePaint node. And in this UpdatePaint node, that's quite hard to actually to do it without being able to show anything. In this UpdatePaint node, you will have to manually create the nodes. So when you have your QtQuick item, it's just something empty with no visual appearance and nothing. So in this UpdatePaint node, the first time you enter it, the first time the component is drawn, or when it is redrawn after being destroyed, you will have to manually create the node that represent your element. So for example, if your item is a simple rectangle, but I guess it will not be a rectangle, you will have to create, for example, a rectangle QSG rectangle node. Oh, it's back. Amazing. I'm very happy. Okay, so I will try to continue this one instead. So UpdatePaint node will be the method to go, and all the classes you will use in this one are QSG something classes. And to update your component, to update the visual of your component, as always, as for usual component in Qt, you have to call update to trigger the draw of your component, the update, the graphical update of your component. It's a lot easier. UpdatePaint node, this one, and actually it's not the simplest one to explain. So you have this one, which is the old node, which is not initialized the first time you enter it. And you have paint node data. So actually, in this case, we don't use it. And actually, I don't remember what was in it. I looked for it sometime. Okay. So in this case, we simply cast the old node to a simple rect node. So a node that will simply represent a rectangle that will be a very simple node to show a texture, for example, show an image, or have a plain blue rectangle, for example. In this case, the node is this one. We test if it was created already or not. So we can say if it's the first time we draw the component. If it's the first time we have to create this node, we have to set it up. So in this case, we simply set the color. And we have to set its size. So in this case, we set it to the full size of our item. So this test is very important, and it means that you really handle the memory and the lifespan of your object manually. So if you have, for example, to draw an equalizer with several bars following the level of the sound, you have to create all those bars manually and to manage their lifetime and their size and color, etc., all manually. In this case, it's quite simple because we only set the color. But if you want to go a bit further, you have to create the vertex manually. You have to assign the textures and the color to vertex manually. So you can go really deep inside it. You can do, I would say, quite anything, only limited by Qt and OpenGL. But it's really some work. So I guess I'm a bit, even more late. Okay, perfect. That's the... Yes. Some things to be careful of when you are in this part. Yes, you have to draw only in the render thread. So only when this method is called, and only from this one, you have to create your object and make change to them, etc. Because the rendering is done in a separated thread, and that creates, of course, as always, as soon as you have threads, problems if you don't pay attention to this. The main thread is blocked during the rendering, which means you can access the data. It doesn't mean it's completely safe, but it means that when you are doing the rendering, at least it is not being modified at the same time. It will not change in the middle of your rendering. All objects you create are running on the rendering thread, so it means if you create I don't know, any object, it will run on this rendering thread and not on the main thread. And it means that communication from this object to the rest of the world, to the main thread, will be queued. So usually signals are synchronous. When you emit the signal, it directly executes all the connected slots. In that case, it will post a message instead that will be processed when thread has some time for itself. And some example of the node that you have available that I will go, just go very fast. The transform node to add the transform capability, same with opacity, same for clipping. This one so geometry, to be able to draw something, to create really a geometry with vertex and being able after to draw a color or a texture on it. And in the geometry node, you have the very simple one, the basic geometry node that lets you handle the geometry and the materials by yourself. So it's the lower level one. You have the simple rect node, which is also for convenience to let you create a rectangle with a specific color of text or texture. No, simply color actually. And the second one, which is simple texture node, which lets you show an image, a simple image in your component. So geometry node, you handle the vertex yourself, point, triangle, blah, 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 blah. Quick example, we create the geometry, we set the drawing mode to lines. So in this case, we simply draw a line. So it's just to draw a single line in your QML side. We set the drawing mode to line, we set the line width, and here we add really the vertex of the drawing, OpenGL, yes, kind of OpenGL vertex. So we create 1 point for the start of the line and 1 point, 1 vertex for the end of the line. Finally, we create our geometry node because this was only the geometry, and we set the geometry on the node. We set the flag, and that's all. All this is done in the painting node. So I think you see that it's quite different from the QPainter, if some of you are used to that. That's really a completely different approach, and you really need some, at least basic OpenGL skills to be able to understand what's going on and how to handle all these different objects. And the geometry node, with material, blah, 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 blah. This one, I will skip it fast. It lets you re-implement shaders. So if you want to create effects directly from C++, it's completely possible. And in that case, we simply create a flat color material. So just to create a red element in QML. So red material and a geometry node. We have already we have already the geometry, and we simply set the material to the one we created here. We say that it owns the material to let it delete automatically at the end of its life, and that's all. And the sum up is in one line. It's quite difficult. If you want more information, it will be quite work. If you have more questions, I can just answer them after, because yes, I've been quite fast through that. And if you simply need to do some quick drawing, you can use this one, which is actually perfectly good when you have no performance problem. And the last part, the last one, about sensors. So you have sensors that are specific to your platform. If you are running on Android, you have no problem at all, because all this is already taken care of. But if you are running, for example, on a custom board, and you have different sensors, probably you will have to write the plugin to handle this information yourself. It means you have to create one plugin, one Qt plugin, that will be used in your application to get you information about the sensor. That's if you want to use Qt class, of course. If you don't want to use Qt classes, it's not a problem. Actually, we're not that late. Okay. Oh. And in that case, we'll see how to handle accelerometer. So the first one, yes, two different classes. QAccelerometer and QAccelerometer reading, that's from C++. If you want to handle that from QML, that's simply accelerometer with no Q, as usual. Okay, so let's say you have your board, actually like this one, you have an accelerometer on it, but of course it doesn't work from scratch because people from DJI just don't know you want to use this one and will not create tons of plugins for tons of different hardware. So you have to create your own one. And to do that, the simplest way is to simply duplicate one from the source code of Qt. So you have different sensors in Qt-based plugin sensors, I think the path is right. And after you have accelerometer and all the other, I can't remember, only one. You have all the different sensors that Qt handle, and so you can just copy it and adapt it to your needs. Usually that's the easiest approach. And one plugin is composed of two different things, so that's really a basic one. A Q sensor plug interface and backend factory, so you have the interface of the plugin, which is made of these two. And then you have your sensor that is handled in a class inherited from Q sensor backend. And what you will do in this one is re-implement all the start-stop pull method to really go and open your file driver, your accelerometer driver, and read periodically from this file to bring back information up to Qt. So open the driver, read, and pause. Yes. Regarding the accelerometer, you have three values, so three acceleration, of course, the X, Y, and Z. And what you see on this image is that Z is the one that goes through the screen if you have a phone, but also if you have something else. And the X and Y coordinates are the coordinates of the screen if you do no modification to the coordinate system. So X and Y will be usually the one you are interested in, particularly if you want to adapt when user rotate the screen. And you have one very convenient way to do that is to set the acceleration mode of the accelerometer to gravity. And by setting that, the accelerometer will do a low pass filter actually on the values and let you get only the direction of the gravity to be able to just change the size, the orientation of the screen. So from this information, it's very easy to do, for example, a rotation on your rotate item of your QML, or to load an alternative UI QML in this case, etc., etc. I'm sorry, I'm too much in advance, so I've already finished and that I went too fast. Okay, and the last part is that Qt have all the tools to let you create your own modern feeling application. It's just about using them and sometimes adapting them a bit to your needs, but everything is already present. From that, the thing is, depends on your company, but possibilities are not always visible to people from marketing or people doing the design. So I would say, enlighten them, tell them what's possible to do with Qt, and then enjoy all this on the target, do animations, do touch gestures, and use sensors, and have fun, and have a very modern feeling application. And more or less, that's all. Thank you for your attention.
Hello and thank you. We experimented with some different operating systems, with Linux and Windows and Android and what's possible. And we figured out that some of them mostly have only 2 touch points and don't give us feedback of 3, 4.
Yes,
and you mentioned a driver there. Do you have any information if this is normal behavior or?
Even in driver, I think even the FDev touch, when we tested it, actually also on our side we had maximum 2 touch points. We haven't tested if it was related to the driver or to FDev touch or to FDev, to be honest. But that's one limitation we already saw. Yes, we also saw. No, yes, even the driver was raising only 2 points. So actually, there's nothing Qt or DevTouch can do about it. I think it really depends on your screen and how you use it. In that case, I can't answer you directly. Yeah. I can show you some real code also, if we have some time, because I skipped that. But
hi, consider we go for this hardcore node approach, no? And we have an application created with nodes, and then we have to display a dialog on top of it, no? And the dialog disappears, and the question is, who takes care about set ordering and the repainting and so? Is it something that is managed by this scene graph, or is it something that has to do in your own application?
When you want to show a dialog on top of the, it depends. If you can use the CuteQuick controls, you can have some quite good dialogues. Thing is, I know for example, with EGLFS, that's not possible because it will create another OpenGL context to have this really layer mechanism working, and so you need to handle that manually. So if you have the QtQuick controls available, you can have dialogues in QtQuick and you don't have to do a lot. Else you have to do your own filtering, event filtering, or simply show a mouse area behind your dialogue, or, yeah.
Thanks.
Hi, I have a question about the scene graph. I imagine that it switches automatically between maybe direct OpenGL, and then if you do more complex stuff, it involves some frame buffer object or some buffer. For example, we tried drawing several rectangles, and it was quite fast on the test machine. And then we added at some point just opacity 0.5 or something, and then performance was heavily impacted and gone down. And okay, it was a slower machine with a slower graphics card.
Yes.
And maybe it's just because then if we introduce opacity, then there will be an opacity node for all items inside this.
Usually it's recommended to use the opacity node directly. When we used it, usually we didn't have to use the opacity node directly. So I can tell, but probably inside the scene graph for the opacity node specifically, there is the right mechanism to handle that properly. Because in your case, you handle that manually with a shader or something like that to do the opacity, or you used an opacity node.
In fact, we were just using plain QML, and afterwards we experimented with a QScene graph routines, and that finally solved our problem, because then we are using a fragment shader to do this.
Yes.
The opacity effect was just some dimming down of the color, and that can be easily done with a fragment shader, and that gave great performance. But I just wondered why this works so well without opacity, and then it with pure QML it breaks down. And I think because before it can just go and paint it immediately, and if we have some opacity in an item and several sub-items, he has to buffer all sub-items into that called frame buffer object or something, and then apply opacity on this. And this is just another copy and indirection. Imagine this is a correct process, as I understand.
I'm not an expert of the scene graph. I know there is here. I don't remember who work at, but there are several people at DJI working on the scene graph. So if you have more in-depth question, they can probably answer. But as soon as you handle the opacity, you have this need to do the blending. When you use no opacity, it's quite easy to handle your component as an opaque one and don't bother about what's under and how you blend with that, etc. And so, yes, it's as soon as you use opacity, you will have a performance drop. Going to the shader will, of course, give you better performance. but I can't tell you really how the scene graph handle this and why there is such a huge performance drop, except from telling you, yes, it costs, opacity costs, that's sure, but...
Okay, thanks.
Oh, in that case, thank you very much.
Thank you.